Hello there and welcome to A2 Maths from June 2018, paper 1, and here we're looking at question 5, a differentiation question. So we have y is equal to 3 sine theta over 2 sine theta plus 2 cos theta, and we want to show that the derivative of this is equal to something over 1 plus sine 2 theta. Okay, so it's going to be pretty long, this one, but let's give it a go. We're going to be using the quotient rule here. We have a fraction that we want to differentiate, so we'll write it as f of x over g of x. And so we're going to treat this as f of x over g of x, and in the formula booklet there is a formula that tells you how to differentiate fractions, basically. So dy by d theta in this case is going to be you differentiate the top function first, then you multiply that by the bottom function, and then you subtract the top function without it being differentiated, and then times that by the differential of the bottom. And then that's all going to be divided by g of theta squared. Okay, so let's get started then. Let's do dy by d theta, and this is going to equal. So the first part is to differentiate the top, so that's going to be 3 cos theta. Then in brackets, that's going to multiply by the g theta function, which is the bottom function, 2 sine theta plus 2 cos theta. Now let's move on to the second part. It's now the top function, that's just f of theta as it was without being differentiated, so that's 3 sine theta. And then we need to multiply that by the bottom function being differentiated. So sine differentiates to cos, so it's going to be 2 cos theta plus, and then cos differentiated is minus sine, so it's going to be minus 2 sine theta. And that's all going to be divided by the bottom function squared, 2 sine theta plus 2 cos theta. And that's all going to be squared. Right, okay, let's now start to expand some brackets and hopefully we start to simplify. So 3 times 2 is 6, cos times sine is just cos theta sine theta. And then expand the second part, it's going to be 6 cos squared theta. Then the second part, it's going to be 6 sine theta cos theta. And the last part, double negative, will make it plus 6 sine squared theta. And we're also going to expand the brackets on the bottom. It's going to become 4 sine squared theta plus 8 cos theta sine theta, and then plus 4 cos squared theta. Right, let's now simplify what we have. So in this case, cos theta sine theta and sine theta cos theta, you can rearrange the order that they're multiplying, and these two things here, one's a positive, one's a negative, and they will cancel each other out. We have 6 cos squared and 6 sine squared on the top, and remember that sine squared plus cos squared equals 1, so 6 sine squared add 6 cos squared must equal 6. So the numerator is going to simplify all the way just down to 6. Same thing will happen on the bottom. It's going to be 4 sine squared plus 4 cos squared. That's going to simplify to 4. And I'm looking at what they want us to turn it into. They want us to turn it into a double angle in terms of sine. Remember that the double angle for sine, sine of 2 theta, is equal to 2 sine theta cos theta. But I have 8 here, so if I times both sides by 4, I get my 8 sine theta cos theta, and that will simplify to 4 sine 2 theta. Okay, let's now simplify what we've got on the top and the bottom. It will simplify to 3 over 2 plus 2 sine theta, sine 2 theta rather. But we only want 1 on the bottom, so what we'll have to do here is we'll have to be really cheeky and pull out the 2 onto the top as a half, and it will then turn into 1 plus sine 2 theta. Okay, and that's what we're looking to show here. So A is equal to 3 over 2. So it's a pretty tricky question here. You'd expect A just to be a whole number, but it does say it's a rational constant, so it can be a fraction. In this case, it is the fraction 3 over 2. There we are, that's the answer to question 5. 5 marks for that. Let's now move on to question 6.